This is RS latch. Now this class is RS latch. So here the RS latch is designed by using NOR gates. These are the NOR gates. So this is the truth table for NOR gates, and this is the overall truth table and the final output of this entire flip-flop latch. This is what is called as a latch. So that means back-to-back connection. This is X and this is Y. These are the two inputs, and this is one NOR gate and this is another NOR gate, and the output of the NOR gate is connected to input of the second, and this is the output of this Q and bar. This is Q and Q and bar, and Q and bar output of the Q and bar is connected one of the input of the first NAND gate, NOR gates. So this is what is how the connection is made like this. Then let us see how the things will be happen, right? So already we know that the truth table of NOR gates, 0 0 means 1, 0 1 means 0, 1 0 means 0, 1 1 means 0. So this is the truth table of NOR. This is very useful while designing, while deriving the output of the latch. So let us see first the inputs. These are the X and Y. X and Y are the inputs, and this is Qn means this is Qn, and Qn plus 1 means actually the people have considered this is the Qn plus 1. No, this is the Qn bar, the complement of this input, where Qn means this is the present state. What is the present state? So before applying inputs, what is the present value? After applying the inputs, then some calculation had been made. So once the inputs are transferred into this, and we will get output. That is output can be called as Qn plus 1. So once the inputs are given, then definitely output will be turned out. That means called next state. That's why it is called as Qn plus 1. That means next stage. So this is the before giving the inputs, what should be the output? Qn. And after giving the inputs, what should be the output? That is called Qn plus 1 state. That is what is next state. Right? This is the truth table explanation. Then coming to the point. First initially 0 0. That means this is 0 and this is 0. Next. So initially the Qn, assume that this is a 0. That means, so this is the 0. Assume that this is the input, present output state is 0 before giving the inputs. Let us check what will be the output after entering these inputs into this NOR gates. So that means, so here the input is 0, then and the next input is already we have considered input. Assume that this is the 0 input in this case, because it is the 0, and we'll verify for that 1 also. What should happen if the present output state is 1? Then so let me verify. So present output is 0 before giving inputs. So 0 is coming to this. So 0 plus 0 plus 0 means, what is 0 plus 0? This becomes 1. So 1. Now this 1 is coming to this, and here 0 is the present input. 1 plus 1 0, 1 0. That means this is 1. Here this 1 is applied because it is back-to-back connection. So 1. So what should be the 1 0, 0 and 1? What's 1 0? 1 0 means output is 0. That means once, so before giving the inputs, we have considered output is equal to 0 like this, and after applying the inputs to this 0 is coming to this, becomes 1, and this becomes, this 1 is applied to this, and 1 plus 0 is 1. That means this is Qn plus 1 is also 0. That means next state is also 0. That means no change. So before giving the input 0 0, if the output is equal to 0, then next state of the output is also 0 after applying inputs. So 0. Next, coming to this, let us verify if the present output is equal to 1 before giving the inputs. So present output is equal to present state is, this is the present state and this is the next state. Present state means before giving the inputs, and next state means after entering the inputs to the system, right? Then this is 1. So 1. Then 1 is coming to this. So 0 is coming to this. 0 1. What is the value of 0 1? 0 1 means 0. And again, sorry, this is 1 and 1 0. 1 0 means 0 is here because the input of this, and this 0 is connected to this. So what is the value? If the two inputs are 0, 0 is applied to this, 0, 0 means once. That means 1. That means, and the present state is equal to 1 and next state is also is equal to 1. Right. This is how it's verified for the when the inputs are 0, zeros. Next, coming to the and coming to this next state 0, 1 are the inputs. This is 0 and this is 1. So let us check what should be the case here. So initially this is the present state of output is equal to 0. Let us assume that. So 0 is coming to this, 1 plus 0. 1 plus 0 is 0 and this 0 is given to this, 0 plus 0 is 1. That means, so here this 0 is coming to this, going to this as input, 0 plus 0 is equals to 1. So here 1. That means present state output is equal to 0 before giving that 0, 1 as inputs, but after giving 0, 1 as input, then the output present state becomes converting into next state is equal to 1. That means this is 1. Next present state is equals to inputs are 0, 0. Next present state output is equal to 1. So that means this is 1. Then 1, 1. This output is equal to 1, 1. 1, 1 is equals to 0. So 0, this 0 is going where? 0 plus 0 is equals to 1. So that means even the present state is equals to 1, present state output, and next state is output is also equals to 1. That means when this case is called, when the inputs are 0, 1, if the present state output is equal to 0, then that will be set to 1 after applying inputs. And if the present state is equal to 1, again this sets to 1, same. That means this is what is called the set. That means if the present state is equal to 0, next state becomes 1 when the inputs are 0, 1. Right? If it is 1, 1, same inputs. That means the next state will become set to 1, whether it is 0 or 1, but next state becomes set to 1. So that's why it is called as set, and this is what is called as reset. And we will see, that means this is equals to set and this is equals to reset, R and S. This is what is called as S and this is what is called as R. So next verify. So if the next coming to this is Qn bar. Next, same, if the inputs are 1, 0, that means this is 1 and this is 0. Then what will happen? If the present state output is equals to 0, then what will happen? The 0 is coming to this, 0, 0. What will become 0, 0 means 1, 1. So 1 here, 1, 1 becomes 0. That means this next state is also not changed. Reset. And let us verify what could be the value if the present state output is equal to 1. So here 1. Then what could be value? This 1 is coming to this 0 plus 1. What is the 0 plus 1? 0 plus 1 is 0. And this 0 is going, and here already 1 plus 0. 1 plus 0 is also equal to 0. That means 0. That means this becomes, even the input is equals to, if the input is equals to 1, if the input is equals to 0, then this becomes 0 set. Next, let us check, verify if the present state is equals to 1, then what should be the value? These are not changed. 1. So 1 here, 1 is coming here. That means if the present output is equal to 1, then we will verify what will be the next state. If the present state is equal to 0, then next state is equals to 0. But now we are verifying present state is equal to 1. So present state is equals to 1. Then what could be the value by applying 1 and 0? So 1 is coming here. 1 plus 0 is equals to 0. Next 0, 0 is coming here. 1 plus 0 is equals to 1. 1 plus 0 is equals to 0. So that means this becomes 0. This is how it is changing to 0. Next coming to the coming to this value 1 1, both are 1 1. That means this is 1 and this is 1. So if the present state is equal to 0, then what should be the value? So this is qn bar. So 0 is coming here, 1 1 1 0. 1 0 means 0, and this 0 is going here. 1 plus 0 is equals to 0. That means the present state is equals to 0, next state is equal to 0, but complex. This is equals to 0 and this is equals to 0. 0 0. Is it possible? No, because if the value is 1 means it should become 0. If the value of 0 means it becomes 1. But both these two inputs are same value. So this is not possible. This is not possible case. Next, let us check for the present state is equals to 1. This is the case. Then what should be the value? This is the 1. This is 1. Let us verify. What could be the value. Then that 1 is coming away. 1 1 1 1 1 1 0. Next this 0 is going away. 1 plus 0 is equal to 0. Same. So this is also same states. It's it's definitely, if it is 1 means it's supposed to be arrived at 0. If it is 0 means arrived at 1. If it is 1 means arrived at 0. But this is 0, this is 0. It's impossible. So this is not valid. So that means these two cases are not valid. That means these two are not valid. So this is how this is verified. Next, so coming to this table, we will explain something about this. That means if the inputs both 0 0, if it is 0, the next state is also 0. If the same two inputs are same, present state output is equal to 0, next state output is also 0. That means, so the implication of this is when the inputs of this flip-flop or latch are 0 0, that means present state is equals to the next state. That means it is nothing but a memory element. If the two inputs are 0 0s, then what should be the present state? The same output will be carried to the next state also, 0 1. And when coming to this 0 and 1, if the present state is equal to 0, next state becomes 1. If the present state is equal to 1, next state becomes 1. That means if the present state is equal to 0, next state becomes 1. Set. This is what is called as set state. This is memory state. This is the set state. Next, coming to this 1 0, if the inputs are 1 0, if the present state is equal to 0, next state is equal to 0. If the present state is equal to 1, next state is equal to 0. That means this is what is called as, and that means if the present state is 0 0, if the present state is equal to 1 means this becomes reset to 1. This is what is called the reset state. And this 1 1, when the inputs are, this is the complication, or this is what is called the race around conditions. It's invalid state. This is the drawback of this circuit. So this is memory state, this is set state because set to 1, and this is reset state, 1 becomes 0. This is what the concept of this latch.